Hi, my name is Allison Falconberry. Today we are going to use a statistical software program, CodeApp, to investigate the relationship between engine displacement and city fuel economy in vehicles. To start with, let's define these two variables. Engine displacement is measured in liters and is the combined swept volume of the pistons inside the cylinders of an engine. And fuel economy is usually measured by city and highway fuel economy. Today we're going to look at city, which is the fuel efficiency measured in miles per gallon in a city driving situation. So braking, accelerating, going around curves. Note that values mean that it has better. So one type of was just cruising the internet and saw that they are planned to launch these A-class of these new cars, and displacements were as low 100. That displacement that I read did not put a relationship between. So to do that, 15, yes, that there is a versus these cars 2000 liters. No more power it created. So from the effect. So this quote to a higher horsepower is less fuel economy. Let's take a look at all of the cars and deduce from these cars. So I'm opening up CodeApp. Okay, and it automatically gives us a table with all of the different variables measured from these 300 vehicles. And particularly, I want to look at engine displacement, since that's what we've been talking about. And right away, I notice a right skew if I put the engine displacement on the x-axis. This means that a lot of cars have lower engine displacements, but if we look even more carefully, there are not a lot of cars like the A200 or the Mercedes A200 that have an engine displacement of 1.3. So let's kind of keep that in mind. Let's add the y-axis, our response variable, and we see right away the relationship is overwhelmingly negative in city fuel economy. Further, the ruler right here, and let's put on the lead. So right here in yellow, you can see the negative slope, negative 3.24. Our increment by 1 liter, we can feel it drop by 3.2. What mean overall? That means that it has a lower gallon. And remember from the intro, clearly a good thing. Okay, we're efficient in this area with higher fuel economy. Okay, off the bat, it does look like that lower displacement results in a higher fuel economy efficiency. So let's do what if I put another variable here. So what if we look at transmission type? When I was looking into this Mercedes A-Class, it mentioned that it had a dual clutch transmission, which is a type of automatic transmission. It says that this type of transmission offers a better fuel economy than most traditional automatic and manual transmissions. So this kind of made me think, maybe transmission does play a role in fuel economy and engine displacement. So let's check it out. Well, sorry about that. Let's check it out. So I'm going to take transmission right here and overlay it onto my scatter plot. So now I can see the values that are yellow or automatic and purple are manual. So what do I notice right away? I'm looking at the difference here. I'm noticing that those with I'm interested in, they have lower fuel economy. So automatic transmission. Interesting, but actually had a specific, it was a it was a semi-automatic dual clutch. Further, I'm going to remove this, just click on remove it. I'm going to create a with the transient variable over here off, and particularly click on and see our now has highlighted those under the Mercedes. See just those highlighted. They're pretty close to the regression with this, but notice none of them are these. So even though this 800 with the 1.2 our ruler and point and this movable point, let's 1.3 falls about here, so here predicts that the 200 engine displacement predicts about 27 miles. Isn't fabulous, isn't off the charts like here, but it is high. Even though it's not off the charts, notice it does is compared to these values below it that feel so. I'm thinking that these will be pretty efficient, not out as long as it follows this regression that we have. All right, so one other I'd like to look. Let's take this 800 off of this model, and to measure, can I use this this 800 series being good enough model? So to do that, we're going to call a real plot, which is a scatter plot of the on the y. So a residual plot help us decide what could fit the data. Okay, so to do that, let's go ahead and put this back into our table, so to get rid of that hierarchy there. And we're actually going to go over here to this plus sign, and we're going to add a new attribute. And let's name this attribute residuals underscore miles per gallon. Just go ahead and hit enter. Okay, so what this is going to do is it's going to calculate residuals for our data over here. So remember, residual is how far value and the regression line. So it's going to measure the distance. We're going to go to edit formula and insert statistical functions and residual right here. Our engine displacement, city, fuel economy, just do that and apply. So now see our residuals have been calculated for each vehicle. I'm going to just move this aside for now. I'm going to craft and I'm going to do my residual plot. Remember, a residual plot, our displacement was our predictor variable to begin with, is still going to be our predictor variable. This time our y-axis is going to be our residual. All right. So what does this? This tells me that the model is maybe thinking fuel economy from engine is really in the area right here where we went into for our Mercedes with an engine displacement of 1.3. I've noticed the reason why I think that this model is not very great. We won't scatter pretty close to zero, meaning we're having small. A great job predicting our relationship. So actually right here, these vehicles, remember they had all these vehicles right here, are pretty, they have joules, it like 17.57 miles per gallon. So where I wanted to predict my Mercedes, my model doesn't do a very, even though I earlier there may be 27 miles per gallon, there's so much variability, it could be, or it could be worse. So residual plot tells me this is the model, maybe I need to do a little better investigating. One thing to do, maybe take away all of the other vehicle types and just look at the transmission. Again, and particularly the semi-automatic. Notice it does the residuals. Maybe looking at that a little bit further. But to summarize, overall, it tends to, we can probably pretty comfortably say lower in displacement has a better fuel economy. Transmission is related. A lot of these that had way better had automatic transmission. They not include the dual transmission like the Mercedes. And remember our plot said that maybe this model isn't the best because of its curve. So it's interpretation of the fuel economy for Mercedes. Probably predict looking at the other type vehicle that, even though it has a pretty low placement, have a pretty good 27 mile and possible. That tends to be the trend here. That could be better. We're just maybe not 100% confident to investigate further. All right, thank you. I enjoyed doing this analysis with you.